before we start solving this equation, we need to rewrite it into standard form. So that will be step one. So step one, rewrite the equation in standard form. Now, this standard form is in your formula booklet, all right? So you don't have really to cram it. And the standard form is this, dy over dx is equals to p of x, which is a function of x, multiplied by y. Oops, that's actually minus, plus, sorry. P of x, y, which will be equal to q of x. So q is also a function of x. Now, this is the standard form. All right. So we need to write that equation in standard form before we start using this method. Before we start finding the integrating factor. So back to the question. So we have cos x dy over dx is equal to y sine x plus sine 2x. All right. So to rewrite it in that form, I'm going to, first of all, I'm going to move this guy to the left. So we'll end up with cos x dy over dx minus y sine x is equals to sine 2x. Okay, next I'm going to divide both sides by cos x. If that makes sense, divide this side by cos x, divide that side by cos x as well. So what we shall end up with is dy over dx minus y sine x over cos x is equal to, now this side we can write as 2 sine x cos x, use your double angle formula, over cos x. Now that and that is gone. What we end up with is a simpler equation, which will be dy over dx minus y tan x will be equal to 2 sine x. Now this is in standard form, all right? And it's much simpler than what we had initially. So step 2 we will be finding, so that was step 1, all right? Now step 2, I'm going to find p of x. So step 2, all right, just go back. All right, so step 2, find p of x. Now p of x is just this bit, all right, tan x but with negative. So p of x will be equal to negative tan x. The best way to find that is just compare it with the original formula in standard form, all right? If you compare it with the original formula here, you can see what p of x is. All right, so step 3, we are going to find the integrating factor. So find the integrating factor. Now the integrating factor will be a to power integral of p of x, which is negative tan x, all right? So which means we need to find the integral of tan x. So integral of negative tan x will be, let's just put the negative out. Well, we can just leave it in, doesn't really matter. So that will be equal to the integral of negative sine x over cos x dx. Um, let's use substitutions. Let u be equal to cos x. Du over dx will be equal to negative sine x, which means dx will be equal to du over negative sine x. And then we can substitute this into this. So what will end up with the integral of negative sine x over u multiplied by du over negative sine x. All right, this guys here will cancel. So we'll end up with the integral of negative 1 over u du, which is just equal to negative ln u. I think I'll just write it below here. No need for integral anymore. Plus c, but we don't write c, which is equal to negative ln c, which was cos x. All right. So once we have that, we can come back to the integrating factor, this guy here, and say that the integrating factor will be equal to e to power negative ln cos x. Is it really? Oops, I think I made a mistake. This is actually a positive, 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 positive. So that's positive. All right. So that will just be because negative and negative cancel. All right. So that e to power ln x, e to power ln cos x, not ln x. Let me write it properly. E to power ln cos x. And that will just be equal to cos x. All right. So our integrating factor is equals to cos x. All right. So step 4. What you're going to do to step 4 is to multiply both sides by the integrating factor. So we are going to multiply basically both sides of this equation by the integrating factor. So what we'll end up with is cos x into bracket dy over dx minus y tan x will be equal to cos x multiplied by 2 sin x. And we just have to simplify that. So this will give us cos x dy over dx minus y cos x tan x is equal to 2 sin x cos x. And then step 5 will be integrate both sides. So which means we are going to integrate this side with respect to x. So cos x dy over dx minus y cos x tan x which will be equal to the integral of 2 sine x cos x with respect to x. Now, what I need you to do is remember what we discussed previously. This bit, we're going to reverse the product rule. So what you'll end up with is, if you reverse the product rule, that means that you're actually multiplying the left-hand side by the integrating factor multiplied by y. All right, that's what it means by reversing the product rule. I'm sure you have noticed that from the previous steps. So what you're going to do here is just to take our integrating factor and multiply by y. So we'll end up with cos y. We can just say it here, cos y will be equal to the integral. Now, this can be written as using double angle formula again, sin 2x dx. And this will give us, this is, I meant to write y cos x. Sorry about that. So what we end up with is y cos x will be equal to, I have to be careful not to make mistakes now, negative cos 2x over 2 plus c. All right, integral of sine x is negative cos x, and then you divide by 2. All right, so that's what we have. That's a general solution. So I'm gonna carry on to find, because I think we have this boundary condition, which means we can find a particular solution. So I'm just gonna add that as step 6. So step 6, find the particular solution. So so this will be at x is equals to 0 and y is equals to 1. So we'll just plug those conditions into our general solution. So what we'll have is 1 multiplied by cos 0 will be equal to negative cos 0 divided by 2 plus c, which means that c will be equal to, right, let me just go step by step, no rush. So 1 will be equal to negative a half plus c. Therefore, c will be equal to 3 over 2. Okay. So I need to see this general solution up here. So going back, so our particular solution will look something like this. Y cos x will be equal to negative cos 2x over 2 plus 3 over 2. So this is implicit solution. You can make it more explicit by multiplying both sides by 2. We'll have 2y cos x will be equal to negative cos 2x plus 3, which means y will be equal to negative cos 2x plus 3 divided by 2 cos x. And that will be our final solution.